Hello everyone. In this video, we will be discussing about reverted gear train. So, I have taken here an example sketch for reverted gear train. When the axis of the first gear, that is the first driver, and the last gear, that is the last driven or the follower, are coaxial. You can able to see here. This is gear 1, which is the driver, which rotates the driven, that is the follower, gear 2, and there is a gear that is called gear 3, which is mounted on the same shaft where the gear 2 is mounted, and it is rotating. So when the gear 2 is rotating in this direction, the gear 3 also will rotate. Now this gear 3 will be the driver, and this is rotating one more gear, that is gear 4, where this gear 4 is mounted on the shaft where the gear 1 is mounted. So when the axis of the first gear, that is the gear 1, and the last gear, so both the first gear and the last gear, if it is on the same axis, then these kind of cases we are calling it as the reverted gear train, and even we can call it as the coaxial shafts. So we'll see how to find out the gear ratio and the train value for this reverted gear train. Now, gear 1. So, let me consider gear 1 is the first driver which drives the gear 2. You can able to see gear 1 is rotating in the clockwise direction, and it makes the gear 2 to rotate in the anti-clockwise direction. In the opposite direction, the gear 2 is rotating. Now, gear 2 and gear 3, that is, this is gear 2 and this is gear 3. These gears are mounted on the same shaft. They form a compound gears, and gear 3 is rotating in the same direction of the gear 2. It is a known fact since it is mounted on the same shaft. Now the next case is this gear 3, now it drives the gear 4. So, and you can able to see this, the gear 3 drives the gear 4 in the same direction as that of the gear 1. So the gear 1 is rotating in clockwise, means even the gear 4 is also rotating in the clockwise direction. So in a reverted gear train, the motion of the first gear and the last gear is same, or like we can say. So how to write the gear ratios and the train values we will see here. So let me consider T1 is the number of teeth on the gear 1, and R1 is the pitch circle radius of the gear 1. So pitch circle radius we know, like from here, from the center of the shaft to the this particular boundary, we call it as the pitch circle radius. And N1 is the speed of the gear 1 in RPM. This is for the gear 1 case. Similarly, let me consider for gear 2, gear 3 and gear 4. So N2, R2 and T2 for gear 2, N3, R3, T3 for gear 3, then N4, R4 and T4 for the gear 4. So all the cases I have written. So here I have written T2, T3, T4 is the number of teeth on the second gear, third gear, fourth gears, and R2, R3, R4 will be the pitch circle radius of the second gear, third gear and fourth gear. Then N2, N3, N4 will be the speed of the second gear, third gear and fourth gear. Here, since the distance between the centers of the shafts of gear 1, gear 2 are as well as gear 3 and gear 4 is same. Here you can observe one thing. The distance between gear 1 and gear 2. So this is gear 1 and gear 2. So the distance between gear 1 to gear 2, similarly gear 3 to gear 4, it is same because both are mounted on what? Same thing. So I can write the radius, like the pitch circle radius. For the gear 1 it is R1, for the gear 4 it is R4. And similarly for the for the gear 2 and gear 3 it is R2 and R3. So I can equate the center distance equation will be R1 plus R2. R1 plus, that is from here to here, R1 plus R2. R1 and R2 will be equal to what? R3 and R4. So from this point to this point it is R1, Again from this point to this point it is R2. So R1 plus R2 will be for fourth and third it will be R3 plus R4. It is same. Also the circular pitch or module of all the gears is assumed to be same. So therefore the number of teeth on each gears is directly proportional to its circumference or radius. So since the radius R1 plus R2 equal to R3 plus R4, so the number of teeth also will remain T1 plus T2 will be equal to T3 plus T4. So these kind of equation, that is the radius, the pitch circle radius equation and even the number of teeth equation, we can use it for all the reverted gear train problems. So the speed ratio will be equal to the always the product of number of teeth on the drivens divided by product of number of teeth on the drivers. This is the speed ratio. Once again I am telling you, it is the ratio of product of number of teeth on the drivens divided by product of number of teeth on the drivers. So the equation will be n1 by n4. The first to the last, n1 by n4, which is equal to T2 into T4 divided T1 into T3. So always the even gears numbers on the numerator and the odd numbers on the denominator, and the train ratio will be the reciprocal of this one. Even here I have not mentioned, but you know that the train ratio will be train value will be n4 by n1, which is equal to T1 into T3 divided by T2 into T4. That is the train value. So where this gear trains are used, the applications. So the reverted gear trains are used in automotive transmissions, lathe back gears, industrial speed reducers, and in clocks, where the minute and hour hand shafts are coaxial. You would have observed in our watches, where both the minute needle and even the second needle, it is present on the same shaft. So that is the example always you can remember for a reverted gear trains. So do not confuse with the reverted gear trains and the compound gear trains, because most of the students they make mistake when they are writing the speed ratio equation and the train value equations. So have a look on this video. It is very simple. Both the first gear and last gear will rotate in the same directions, means we are calling that as the reverted gear train. And there is no change in the number of teeth, that is the right hand side, the even numbers on the numerator, the odd numbers on the denominator. Thank you.